This week's topic is based on queries, and we'll be linking tabular data with spatial data. So we're using tables in ArcGIS, and there are two types of tables. So the first one is called the attribute table, and the attribute table stores attributes of map features, and it's associated with a spatial data layer. And again, spatial data layer just means that this layer has location attached to it, such as geographic coordinate system or a projected coordinate system. And next week we'll be going over projections and coordinate systems. But for this week, we'll be only focusing on attribute tables and queries, as well as joining tables. But again, attribute tables has special fields for spatial information. And we can see in this example here that our attribute information are, for example, name or state name. We could also have attribute information based on the year of the population, such as population 1998 or population 1997. Another type of table is called a standalone table. And a standalone table stores any tabular data, and this is not associated with spatial data. So, but you could add spatial data, you could add an longitude and latitude to a standalone table, but a standalone table is not associated with that. And we could see that our fields are different between the two tables. So we could see OID for the standalone table field, and for the attribute table field, we see FID. And this is basically giving each feature a unique ID. So the FID in this field is giving each feature in this layer a unique ID to separate it from the other layers, from the other features, I mean. So these are examples of standalone tables. We have the DBase files, Excel files, info files, ASCII text files. Within that is the Excel CSV files and records from SQL database systems. So these are parts of a table. I used a screenshot of a table example in ArcGIS Online. So again, we have our title. The title here in this example is ACS Total Population, taken from the US Census Bureau. And again, we have our fields. Each column is a field. And we have records. Each row is a record. And we have a status bar. So this attribute table has 1,772 records. And if you want to get more information about a specific field, such as you want to sort ascend or sort descend or summarize the statistics to see what's the maximum value here or the minimum value for area of land, you will click on this option button. So again, for queries, they extract certain records from a map or table, and the records meet certain criteria. So you could have aspatial queries, and aspatial queries, this is an example. You select all parcels with value greater than 100,000. And another type of query is the spatial queries. And an example of that is select all parcels that lie completely within the floodplain. So for spatial queries, you're going to have phrases such as completely within, or intersect, or within 20 miles. So you are dealing with the parcels and the location within the parcels, or next to that specific parcel that you're interested in. Whereas aspatial queries, you're going to have phrases such as greater than, less than, equal to. So again, in our ArcGIS Online, this is called filter. So to use queries and to analyze your data, you'll be using the filter symbology, the filter style. So there are three different types of queries. We have interactive selection, and interactive selection is you choose features by pointing to them on the screen. So for example, if when I open ArcMap, I'm in ArcGIS Online and our map tab, I have Lab 5 data and manual selection, like we see here, interactive selection, you would click on a parcel and that is interactive selection. So we're looking at the attributes of that specific polygon. Here, this is the Carbon County. We have the name and the different information such as the demographics from ages 22 to 64. The population of that is 9,139. And we have other information. If you scroll down, we have populations in a certain year, such as 2000. So again, this is interactive selection when you select on here. Again, this is using Map Viewer in our ArcGIS Online account. We could also open this data and open in Map Viewer Classic. I do want to show you both ways because for your lab you will either be doing tutorials on Map Viewer or Map Viewer Classic. Map Viewer is an updated version of Map Viewer Classic, but I still think it's beneficial for you to see the difference between the two and where you could filter the data. So again, here we have our layers. We have 3 layers, and as a recap, you would, turn it on, off. I'm going to duplicate this tab and open it in Map Viewer Classic so you could see this data in both ways. So I am going to click and open Map Viewer Classic. So this is Map Viewer Classic. I have my Lab 5 data here. Again, the map is the same. We have our polygon layer, which is our US counties. And I could do the same thing with interactive selection. I just need to click on a county and I get a pop-up box. Again, this is Natrona County. The population 2000 is 66,533. So again, you could use either one. Back to our slide. So select by attribute is the second type of query. You select features based on attribute criteria. So for example, select all features that have a population in 2000 that is greater than 5,000. So this is an aspatial query. So to manage that, in the map viewer, you would go to, again, hover over each icon to find the filter. This is the filter icon. You're going to click Add Expression to do our query. Let's see. Because my US counties is selected, we know it's selected because of the blue bar here. I am going to look at population 2000. These are your options here. Is not, excludes, includes, is at least, greater than. So this populated, so population 2000 is greater than 9,000, I am going to save this expression. Before I do want you to look at the tables. So before I do this expression, we have 3,069 records. And when I add this expression, we're going to see that it's going to reduce because we are looking at only population 2000 that is greater than 9,000. So once we add this expression, we should see it updated here, and this should have updated. Let me do another. Let's do name is Washington. Name is Washington, save. Okay, so that one updated our records. So I don't know why the other one did not change, but here we see our name, it only selected Washington. So again, this is an example of an aspatial query. So it reduced our records to 31. And the same here, you could do it on the Map Viewer Classic, and we have our layer tab here. So you would click on this to show contents of the map, and this will show us our map legend. But we are looking at the US counties, so you would filter. And we do want to change this to name. So name is, type in Washington, and apply filter. So we could open our attribute table. When we open our attribute table, again, we have 31 features selected, or 31 records selected. So you could do either or in Map Viewer Classic or Map Viewer. And to clear the selection, let's click on this tab, clear selection. So you click on these three tabs and you clear the selection, and it should have cleared. Let's go to filters and click remove filter. So now when we look at our attribute table, we have our, after we cleared that query, we again have 3,069. Okay. And the same here, you would clear it by this eraser button. Or you would clear it by filters and remove filter. So those are the two ways to do that on Map Viewer Classic and Map Viewer. The third type of query is select by location, and this select features based on their spatial relationships, such as the phrases within, contain within. So here we have some examples to mess with our data. Population 1990 is greater than 1 million, so this will select regions that have a population that is greater than 1 million. So again, using select by attribute, we can select features that meet one or several conditions or criteria. One set of tools that we use for our selection is set algebra. Selection conditions are formalized using set algebra. So these are examples of set algebra: less than, greater than, equal to, less than or equal, greater than or equal to, and not equal. So again, if you want to look at a population that is greater than 5,000, you have to be careful on which one you're doing. So greater than, so population greater than 5,000, when you do this type of query, you're gonna get results that are starting with 5,001. Okay, so when you run this query, it's going to be 5,001 and above. But if you do greater than or equal to, you will be getting the population that is greater than or equal to 5,000. So if you do want the 5,000, make sure your query has greater than or equal to. So you're going to get 5,000 and above. So keep that in mind when you are working with queries and the set algebra. So again, we did work with set algebra. We could see here in our filters that we have greater than, is not, is at least. Using select by attribute, we can select features that meet one or several conditions or criteria. One set of tools that we use for our selection is set algebra. For example, either less than or equal to, greater than or equal to. Another set operations for selection are Boolean algebra. So for Boolean algebra, you use or, and, or not to select features. So it's most often used to combine set algebra conditions and create compound spatial selections. So for the AND operation, the AND operator requires conditions on both sides of the operation to be true. So when it filters this type of criteria, it needs to be accurate on both sides. So this typically decreases selection sets. So select all counties with population density less than 50 square meters, which are within state of Vermont. So again, select counties must have less than 50 density and must be within the state of Vermont. So it needs to fit both of these criteria for it to be selected. We could see in this example, this is another query option in ArcGIS Pro. We're not using ArcGIS Pro, but it has the same format like we have with Map Viewer and Map Viewer Classic. And we can see here they're looking at the field population 07 square miles is less than 50 and the state name is equal to Vermont. So our Boolean set is the word and we could see that the record selected is 6 out of 130. So it was very specific to only 6 records. And we could see these 6 records are highlighted on the map. And here we could see on our Map Viewer Classic that we do have the option when you click Add Expression, we are getting the Boolean algebra set and. So population 2000 is greater than 90,032 and name is Washington. So again we have 6 selected. So for the Boolean algebra OR, the operator requires only one condition to be true. Typically, when you use the OR algebra set, this Boolean algebra set, we are either we are increasing or adding to the selection. So you're going to select all counties with population density less than 50 square meters or are within state of Vermont. So again, you're either choosing, when you run this query, you are getting both. So that's why it adds to the selection. So we could see our records increased to 32. So here we have population 07 square miles is less than 50 or state name is equal to Vermont. We could see it could either satisfy one or the other, and we have 32 records compared to AND, which has 6 records. And the Boolean algebra NOT is a negation operation. This select records that do not equal a specified condition. It works like the less than greater sign together in the set algebra. So select those, an example is select those counties that are not within New York State using Boolean algebra. So when you run this type of query, you're going to have all other states that are not New York. So again, states for which population 2000 is greater than, it looks like 2 million, it only selected 7. And it's also highlighted in the map like we see here when we run it through ArcMap. Map Viewer. So again, you could always mess with these types of queries. For your lab exercise, you will be working with queries in your tutorials. So example query, select from cities where population 1990 is greater or equal to 5 million. So again, when you put that in, population 1990 greater than 5 million, I showed you how to do it on Map Viewer and Map Viewer Classic. And another type of operator is the like operator. And this is beneficial to know. I'm not sure if this works with our ArcMap viewer, but if you wanted to find a state name that starts with Miss, you would do this type of expression, state name like Miss. So you have your 2 single quotation marks and Miss. So this expression would select Mississippi and Missouri among the USA state names. Okay, so for select by location, this is another type of attribute feature. Query field feature. We have select counties that completely contain state capitals. So this highlighted counties that have state capitals with the star. Select counties that are within 200 miles of Denver. So here's Denver. This is the counties that are within 200 miles of Denver. Again, we are using phrases such as completely within. This is within 20 miles. So select cities that are within 20 miles of an interstate highway. So these cities are within 20 miles of an interstate highway. And select cities that are completely within counties named Washington. So you're dealing with spatial location query. So here on our ArcMap and ArcMap Viewer, it is different than this type of format, but in your tutorials for lab class, we won't be doing select by location. We will be doing labs on that later, and I will do a walkthrough on that for our ArcMap, for our Map Viewer and at Map Viewer Classic. Here we have another phrase that makes it a spatial query, are within a distance of. So select cities within 100 meters of a river or railroad. That's an example. So this operator creates buffers using the buffer distance around the source features and returns all the features intersecting the buffer zones. And another phrase are within, finding features that are within contained by point features, and finding features that are within line features. And another example is finding features that are within or contained by polygon features. So to be selected, the geometry of the target feature must fall inside the geometry of the source feature. So again, in this example, Dallas County is completely contained within and does not touch the state of Texas boundary. And the phrase contain, these are finding features that contain point features and finding features that contain line features, as well as finding features that contain polygon features. To be selected, the geometry of the source feature must fall inside the geometry of the target feature, including its boundaries. And this is another select by location is when you intersect. So we just went over the attribute table and how to filter out the attribute table by using the filter icon. So again, you find it here in Open Map in the map viewer by clicking filter icon, and you add your expression here on what you're interested in. Here we have it updated to showing counties. Our name is Washington. And then you could save this layer and update it to how you have it here and rename it. So, and then in your Map Viewer Classic, again, your filter is here underneath your layer, and you're going to click this filter. And again, we were doing state name is Washington. So it highlighted Washington, and then you can look at your table to see the update, and you have 39 features. So again, that's it for our lecture today on attribute table and select by location and manually selecting as well as selecting our attributes. Okay, thank you for watching.